Hello, everybody. This is Coach Rouser here. So, in this video, what I want to go ahead and address is how to find variables within the surface area, and when you're given a surface area of cylinders, cones, and this works out with prisms too. You just have to go ahead and work out the formulas. And then the other aspect I want to focus on is what's the actual height of the base in comparison to the actual height of the figure. And I think that's one of the main things that confuses a lot of students too. So. Now, one thing that we have to understand is that let's say we have a water bottle and say it's standing like this. It's standing upwards like this, okay? The water bottle. And this water bottle is considered the height, right? So if I have this height of this water bottle that's standing up, then that'll be considered the height of the figure. Now, sometimes you may have a water bottle and it's going to go ahead and just be laying down and you're going to have to go ahead and figure out what the actual height of it is. Nicely, it's not this way. You want to go ahead and just standing straight up. Now, that's when I was just using cylinders. Now, when using like prisms, and that's why I use this example right here with the robot, is that if you can go ahead and identify what's the actual height of this robot, okay? So the height would be considered from here to here. So that's the height of the figure, okay? So that's the prism in this case. Now I use the robot to go ahead and to help out and for you to go and see what the height of this prism is visually. Now, but let's say it's laying down, right? So we're laying this robot down, and that you see that, oh, maybe that this may be the base of it, okay? That's laying down. Now, this being said, if you're looking for the height of this part, that would be considered the height of the base. Okay, so let me just highlight that so I can go ahead and emphasize it. Let's use different colors, use purple. So this part right, this line right here is considered the height of it. Okay, because it's laying down. Now, that being said, this prism could go ahead and be changing. It can be either a triangle, it can go ahead and be a regular polygon, and so forth. But you just have to go ahead and specify where is the base located, and identifying what type of figure or what type of polygon it is. So in this case, if I was going to draw this like in 2D, it'll be something like this. So this shape is actually located here. Okay, and so that's going to be considered the base, okay, of the figure. Okay, now that being said, when you use these aspects, it happens also in the previous section, and it can also happen in this one too. So what I want to go ahead and work with also well, so I just wanted to point that out. Now, sometimes you're given a problem where, oh, so they gave you a lateral surface area of 330 pi kilometers squared, and they give you a height of 15 kilometers. Find the height of the cylinder. So if we're trying to figure this out, then I have to go ahead and understand what I'm looking for. I'm looking for the L, and I'm looking for the L, which is going to be 330 pi. I have the height, which is 15, and I'm looking for the radius in this case. So I'm going to use my formulas of what I know. So in this case, yes, it will be this L that I have here. So if I want to go ahead and focus on that, I can go ahead and focus on that one in particular. So L is equal to 2 pi RH. So L is equal to 2 pi RH. And so if I go ahead and put this, I'll put all my given values in here, then it helps me out. So I know this is 330 pi, which is equal to 2 pi, which is, what's my R? I have no idea. My H is 15. And so when I focus on this one, now I have an idea of where and what I need to eliminate. So I can eliminate these pi's. Why? Because they're on both sides of the equal sign, and they can get eliminated from there. Now, the other part too is that I'll have 330 is equal to 2 times R times 15. So 2 times 15 gives you 30R, and then 330. Now next step, divide by 30. And so R is equal to 11. Okay, so 11 what? 11 kilometers. Always understand that there's always units involved in your values. So R is equal to 11 in this case. So this will be 11 kilometers. Okay, so that's one of the examples that we have to go and work with. Now, let's go ahead and close this, guys. Okay, so as we're going with this, let's go ahead and look at another example. Zooming out. Okay, so let's say we're trying to figure out number 10. Okay, get rid of this one for now. So let's say we're trying to figure out number 10 and see how it's solved and so forth. So given a total surface area of, so that's S is equal to 145 pi yards squared and a radius of 10 yards, find the slant height. Now, here's the thing, and it goes back to slant height because this is the one that sometimes throws off students. So R is equal to 10, and then the slant height, which is a little cursive, is equal to something. We don't know what it is. Now, it helps to go ahead and have the formula chart. So make sure you go and have at least the formulas written down for you next to you for you to use or somewhere. Okay, so S is equal to L plus 2 pi R. Now, here's the thing that you're going to have to do. So it's asking for S, and it's asking for the slant height. So that means I need to go ahead and use this one right here. So I'm going to replace that, or replace this whole entire part, which represents L. Yeah, represents L, and I'm going to replace it right here. And the reason I'm doing that is because if I can go ahead and identify what is going to be my L, what's my full formula, then I have all this to go ahead and use to go ahead and solve for L. Okay. Let's plug it in. Okay, never mind. Going all the way down here. I'm trying to move this, guys. I'm trying to get y'all space. Okay, so so let's plug in what we know. So I know that I have S, which is right here, and that's going to be here. I know that I have 10, which is going to be my R's. And so from here, my S is 145 pi. And then you also have pi times 10 times L plus pi 10 squared. Okay, now here's the thing. Now, if I have pi in each one of these parts, then I can go ahead and eliminate it because they're all shared. So eliminate it, eliminate it, eliminate it. So I have 145, which is equal to 10L plus 10 squared. And so now from here, let's go ahead and make another row. 10L plus 10 squared is 100, guys. Zoom in. So that means minus 10, minus 11. Minus 100, minus 100. And so that means that that's going to be 10L, and that's going to be 45 left over. And then you can divide by 10, and then my L is going to be 4.5. Okay? So this is going to be 4.5 for this problem. So that's going to be the slant height. So 4.5 yards. Okay? So there you go. That's going to be the one for slant height of a cone and how to find it. Okay? When you're given that total surface area. Okay. Now the next part, I'll probably do one of these, is going to go ahead and talk about the grade circle. Now, when you're given a grade circle, all it's saying is that we're trying to take that little shade apart of the whole entire sphere. Now, so in this sphere, we're trying to go ahead and slice it. So maybe if you saw this part, it could help. So if you have like a tomato and you go ahead and slice it, and if I was gonna go ahead and pull this little slice out, then the slice that comes out is gonna look like a circle. So now this part is considered the great circle because it's considered one of these slices. So now if you had like a tomato, kind of looks like something like that. So if you have this tomato, it'll be a slice of it. So that's initially what this is. Now, if we go back to our example here, it's asking find a surface area of a sphere when you're given the great with the great circle of 121 pi. Now, this being said, so if I'm given a great circle, that means I got to find the area. I'm given the area of a circle, and so area is equal to pi r squared. And so from here, 121 pi, that's going to go ahead and be equal to your area because it's right here. So what we're going to go ahead and do is that we're going to take that slice, this slice in here, we're going to take the area of it and we're going to replace it with that. So it's 121 pi, which is equal to pi r squared. And so from here, we can just go ahead and cancel them out because they both have them. So 121 is equal to r squared. Next step I can go ahead and do is square root it. So r is equal to 11. Okay, so that's it. So and that's your radius that you need to go ahead and use. So my radius here is 11 centimeters. Now, if you're asked to go ahead and find the surface area of this figure, then obviously that you can go ahead and use this formula right here. Use that, plug it in. So you'll have S is equal to 4 pi r squared. And then you have 4 pi, and then my r is going to be 11 squared. And then from here, you can go ahead and have 4 pi times 121. And then when you multiply that out, you'll get 4, 8, 4, and then you have pi. And that's going to be my surface area. So 484 pi centimeters squared. Okay? Now, let's see. Make sure you leave it in terms of pi. So that means there's no decimals. Unless it changes otherwise. So you're just throwing it out there for you. Okay? So that's it for the video. Hopefully this helped you out with the great circles, the heights of the prisms, and also how to find the variables when you're given the surface area or lateral surface area of figures. Okay? All right, guys. Tune into the next video.